Now we will start with surds, radicals, roots. They are synonyms. Okay, so surd, radical, radical, or root of something, square root, cubic root. They're all kind of synonyms. So in the first question, it says determine whether each number is a surd. This means that determine whether this number, remember there is a word irrational numbers, the numbers that are under the root that cannot be taken out. So for example, this is an irrational number, so it's a surd. This one is a surd. This one though, it's not an irrational number. This is a rational number. This is an integer. As a matter of fact, this is equal to 6. So that's why this is not a surd. Oops, not a surd. This one is a surd because this is irrational number. This cannot be taken out of the bracket of the radical sign. So root 72 is some random unknown number. Root 72 cannot be calculated. By the way, if it's a surd, find its value correct to 4 decimal places. Just type it in into any calculator. It doesn't matter, and you may find the the value. So we have, for example, root 5. Let me find the first one. So it's something like 2 point, I don't know whether you see this, 2.23. So never mind, just I'm going to write down 2 point, correct to for decimal places, 2.2361. So this is the value. This is not a surd, so that's why we just can leave this as it is. This one is surd. Just type it in into the calculator and see what is the value of this, for example. And when you have a fraction, don't be scared. So here, this one is a surd as well, because 10 cannot be taken out of the radical sign. This is a surd. This is irrational number. But this one, though, is a rational. This is not a surd. This is completely normal number. It's 1/8. And everything that can be expressed as a fraction is a rational, so it's not a surd. So these are the types of numbers. Consider, okay, I'm gonna leave second for yourself. Just find how many numbers are surds. And by the way, the hint is find the number of numbers that are not surd. So for example, root 4 is not a surd, root 9 is not a surd, root 16 is not a surd, root 25 is not a surd, and root 36, and there are a bunch of numbers that are not a surd, so not a surd, okay, or in other words, they are rational, okay, they're rational, and by finding, by the way, root 1, I completely, okay, let me move them. So root 1 is not a surd, okay, or they are normal rational numbers, okay, 1, root 4, root 9, they're normal numbers, and so on. You'll find the number of rational numbers, the numbers that are not surds, and then to answer the question, you may subtract this number from 1,000. So whatever you find here, the number of numbers here, just subtract from 1,000, and that will be your answer. So that's a hint for you. So the next one, simplify. For example, let's do, I don't know, let's do A. So in the third A, it's really easy. Root 3 squared is just root 3 times root 3, right? So root 3 squared, you may write the answer right away that it's just, by the way, I'm gonna show the longer version. The longer way how you can do this is just you multiply the numbers that are under the root sign. So when you have the same roots, so you can multiply 3 by 3. That's root 9, and root 9 is just 3, right? It's a normal number. Do we have something, for example, in I, we have in the same thing. You may square, so you may square the top and the bottom separately. So 1 squared is just 1, and root 2 squared, by following the same logic as was in A, I can say that that would be 2. So when you have a third, just a root, for example, of 5, and you want to square this, you're going to get 5, right? So for example, here, again, I'm going to separately square them. This squared is 25, and this squared is just 5. Okay, so the answer would be 5 if you simplify completely. The same goes with this one. Separately, I square the top, that's 100, and separately I square this, that's going to be, oops, that's going to be 5. So the final answer is 20. The final step is just the division, just to complete the thing. So whenever you have, I don't know, square root of 6 squared, that's going to be 6, right? So because you square the root, that root will be gone eventually. Why I cannot erase this? Okay, so do we have something? So there are a bunch of questions. So for example, again here, you square the top separately, and since it doesn't have a root here, so I square as a normal number, but here, since I have a root, that root will be just gone. So 4 over 11 would be the answer. The same goes with this one. I square this, but it doesn't matter, so it's just 1, and root 3 squared, that's going to be just 3, and root is gone, or the third is gone, or radical is gone. So in B and C, it will be a little bit difficult, a little bit different, because it's cubed. We have cubed, so the name, the idea is you multiply them 3 times, right? That was the true meaning of the power. It just shows how many times you need to multiply those numbers together. So cubed means you multiply this 3 times, right? So here you may say that this times this will give me this 2 together. This 2 together will give me just 3, right? Root 3 times root 3. This is 3. So the answer would be 3 and root 3. Okay, so that's the final answer. And the same goes with the C one. Here, though, I multiply root 3 how many times? Pause the video, think about this. How many times do I need to multiply root 3 here? I need to multiply root 3 5 times, right? Root 3 times root 3 times root 3 times root 3, because there is in the 5th power. So these two will give me 3. These two together will give me 3 as well. And there is a multiplication sign between them. So I'm going to get 9 and 1 root 3 that is left alone. So it doesn't have a pair. So that's the answer. Can I solve something else, or I'm gonna leave these two questions for the next video? That's it for now.